All right, everyone. It is March 9th. It is now about 4:29, about 4:30. I would like to introduce to you somebody who has been a very great friend of the Skyline Biotechnology program, basically forever. I think since I've been here, and I remember a conference a long time ago at City College, going there and kind of meeting Jim for the first time. Jim is a classic Southern Californian who was transplanted here a long time ago. So he is all Bay Area now. He's at Solano College, and he has one of two, and I think one of 12, 15 bachelor's programs at community colleges. He will tell you, but for very cheap, you can get a degree in biotechnology manufacturing, which is kind of, well, there's two programs here in California that will do that. But again, this is one that you can do from your house. And he'll talk about how we have a lot of synergy. And then, again, like I said before, Jim was a really good friend in the Bay Area. A lot of us in biotechnology know one another, are very familiar with each other's programs. And part of that's being in a group that's kind of around Jim and talking with Jim and having beers after conferences, doing activities like, going to Disneyland and shooting up space invaders on that. So with this, I'll leave it. Jim is a very unique person, and he's in a very special spot to kind of help all of us here, especially in biotechnology.
Excellent. Thanks for the introduction, Nick. And again, we have a really close relationship. We're on speed dial. And we also have a relationship with all of the faculty that teach biotechnology in the state of California, and also all of the faculty that teach biotechnology across the United States. And so we're also on speed dial with biotech faculty in Pennsylvania, Wisconsin, in New Orleans, Louisiana, etc. So what I'd like to talk about today is give my take on the biotechnology field, and I call it medicines, microbes, and money. That is, I'm going to try to convince you that you were born at exactly the right time, in exactly the right place. That is, there at Skyline College, you are in the center of the world for the field of biotechnology. There is no better place in the United States where you could be in order to pursue a career in biotechnology. There's no better place in the world that you could be in order to pursue a career in biotechnology. And then think about the timing. I usually give this talk face to face. Why are we across the screen? Because of a worldwide pandemic. What is the way out of this pandemic? Biotechnology. Biotechnology is going to provide the means of us meeting face to face once again. We're going to have an economic downturn. What is the way out of the economic downturn? The field of biotechnology. Biotechnology is going to lead the way out of this. And so I'd like to give you my take on biotechnology. This is one of our former students, Lisbeth, and she is at BioMarin, and she is now making viruses for gene therapy. These are viruses that deliver not a viral payload, but deliver a gene that's missing in usually children that have a inherited genetic disorder. And so I'm going to try to convince you that this field has fundamentally changed the human condition. It fundamentally changed what it means to be human. I'm going to try to convince you, again, that you're in exactly the right place at exactly the right time. I'm going to try to convince you that this is the field for you. And I'm going to try to, again, underscore the importance of this field. So here's a quote from Freeman Dyson, who's a physicist, but really became a futurist, trying to project the future. The 20th century was the century of physics, and the 21st century will be the century of biology. Biology is now bigger than physics, as measured by the size of the budgets, the size of the workforce, or the output of major discoveries. It is likely that biotechnology will dominate our lives and our economic activities in the second half of the 21st century, the way that computer technology dominated our lives and our economy in the second half of the 20th. That is, what Freeman Dyson is saying here is that biotech is going to emerge as being bigger than the internet. Everything that you do, every component of your life, from what you eat to what you wear, to especially the medicines that you take, will be dominated by biotechnology. And that's emerging. And again, it's emerging in the Bay Area like nowhere else in the world. So I'd like you to pretend that you are living 100 years ago. And as I scan you, you're looking a little old. That is, your life is half over. By the way, half of you have died already. You probably are going to have maybe 6, 7, 8, 9, 10 children, because you know that half of them are going to die. Remember, it doesn't matter if you're rich or poor. And if you look at historical figures, remember Abraham Lincoln lost 3 out of 4 sons to childhood illnesses. Thomas Jefferson lost 3 out of 5 children. That is, this is just the way that it was. You would lose half of your children. And again, if you are a fan of Game of Thrones, for example, when you get north of the wall, they have adopted a practice that some societies adopted in the Middle Ages. You don't name your children until they're 2, because you don't want to get too attached to them, because half of them are going to die. And what did they die of? Tuberculosis, pneumonia, influenza, diphtheria, smallpox. These are all horrendous diseases. If you want to get a sample for it, go on YouTube and just Google one of these, and I'll recommend Google baby with pertussis, a baby with whooping cough, and it gives you an idea of just how horrendous these diseases were. Now, these are largely now largely cured. And I hate to tell you, you're going to die, but you're going to die of heart disease, cancer, stroke, diabetes, renal disease. But the change is you're going to die in your 80s or 90s, and half of the children that are born today will live into the hundreds. And you expect your children to live. Now, going from guaranteed that you're going to lose children to expecting your children to live, I contend that that is a fundamental change in the human condition. Dying in your 30s versus dying in your 80s or 90s, I contend that that's a fundamental change in the human condition. And what precipitated this change? What is the cause? Biotechnology. Vaccines. And again, vaccines are the way out of us being across a computer screen and being face to face. Once again, antibiotics. Half of you probably are alive today because you survived a bacterial infection through a treatment with antibiotics that wouldn't have been available before 1945. Better nutrition. When you have better nutrition, your immune system works better and you can fight off disease. And public health measures. It's always bad to have fecally flavored water. So it's good to treat your sewage. And that's not just an icky factor, because many diseases are transmitted by a fecal oral route. And then you, by putting a lot of money, and we put a lot of money into sewage treatment, you save even more money by not having to treat the diseases that are caused by that. And so there's a role for everyone. Sometimes people tell me, I'm not very sciencey. There are elements in biotechnology that are there for you. And so you can have scientists participating in research, healthcare workers, technicians, and we train a lot of technicians, and technicians move up, move up. There are places to go in quality assurance. There are places for writers. There are places for information technology. If you're interested in business, and I always tell business majors, if you're interested in making money, I think you're a fool to go into any other field other than pharmaceutical manufacturing. It is the most lucrative of all businesses. The margins are the greatest. If you're interested in business, this is a really, really interesting business. And the business side is as important as the science side, which we'll cover next. Quality control, regulatory compliance, that is, making sure that your company is manufacturing these drugs in a way that they comply with the very, very strict regulations that are imposed upon you by the federal government, specifically the Food and Drug Administration. And then lawyers can talk about can secure the intellectual property for a biotech company. Okay, so what is biotech? Well, it's the use of living organisms to produce value-added products in any type of manufacturing. In any type of manufacturing, there is going to be a raw material, a process, and then a finished product. And the finished product is worth more than the raw material. It has to be, or otherwise you wouldn't bother doing it. And therefore, the value is added by the process. In biotechnology, the process involves a living organism. Now, in this general definition of the old biotechnology, what happens in my neighboring county of Napa is biotechnology. What they do is they take a tank full of crushed grape juice, and a bottle of that grape juice is worth about $8 a bottle. A bottle of Welch's grape juice is about $1, but the Napa wine grapes have a fancy French name, Cabernet Sauvignon, Sauvignon Blanc, Merlot. And because of that fancy French name, it's worth more. But you add a yeast cell, the yeast takes the sugar and converts it to alcohol and carbon dioxide that you vent off, and then that $8 bottle of grape juice becomes a $125 bottle of wine. The value is added. Now, I'll ask you, who did the work? The cells. Living cells did the work. This wasn't a chemical transformation. This was a transformation accomplished by a living cell. You turn something worth $8 into something worth $125. And the new biotechnology is not all that different. And so the new biotechnology definition, what happens at Genentech, really under 10 miles from your campus. The birthplace of biotech was 10 miles from your campus. The new definition is the use of genetically engineered organisms to produce pharmaceutically active proteins. That is, you make medicines using genetically engineered cells. In the old days, to make aspirin or other small molecule pharmaceuticals, you would mix some chemicals together in a vat, and they would interact with one another, undergo a chemical reaction, and then out would pop the pharmaceutical. In this case, it's not very different than what Napa does. You fill a tank with sugary solution, and then you put in this genetically engineered organism. It has a human gene that's been inserted in it, human information. The genetically engineered organism takes that sugar, and now rather than producing alcohol, it makes it a protein that can serve as a medicine. And that protein then is worth many, many times its weight in gold. There is a protein called granulocyte colony stimulating factor made by Amgen in Thousand Oaks. It's worth $1 million a gram. That's 100,000 times its weight in gold. And what was the raw material? Sugar. Who did it? The organism. It's a living cell that is carrying this out. And very, very commonly, these proteins are treating a disease called an unmet medical condition. That is, treating a disease for which there is no treatment. Let me say that again. Not for which there is no cure, but for which there is no treatment. That is, before these medicines were produced, if you caught these medicines, or if you had this disease or this condition, there was nothing that medical science could do to intervene in that. You were sort of stuck with it. So let me pause for a minute and answer a question. What would you say the most popular career choice for someone with a degree in biotechnology? So for our biotechnology degree, often they will go to work with a biotech company, and you will start out as a technician. But what I like about biotech, and I'm going to stress this several times in this talk, in the biotech industry, the starting salary is pretty good. Our students start at about $22.50 an hour. So that's not bad. And then if you work overtime, you get more. If you work graveyard shift, it's 15% more than that. So that's not bad. But then what I've always liked about the field of biotech is the ability for upward mobility, that is the ability to move up, move up, move up, move up. And very, very often, the head of the company will have started out as technician level 1 and then went up, went up, went up, and went up. Good. So here's some examples of drugs. And again, they're sitting on the shelf next to traditional pharmaceuticals that were produced by big pharma, the old-fashioned way, by mixing chemicals together. This is a great drug, Herceptin. It's made across the street from my lab at Genentech Vacaville. And this is an antibody that targets an especially aggressive type of breast cancer. Women diagnosed with this breast cancer before Herceptin, the physician would say, get your affairs in order. I can treat you with chemotherapy, but you're still, even with chemotherapy, you're not going to last the year. So I would recommend you say goodbye to all of your relatives, maybe take a trip back east, and in order to say goodbye. Now, with Herceptin, in conjunction with chemotherapy, these women are living past the 5-year mark. And so it's a treatment, maybe not a cure, although there are cures for cancer coming. But this really makes a difference to families. And so if you're in this field, at the end of the day, you helped produce a drug like this that saved somebody's mom. Now, when you save somebody's mom, you've saved somebody's daughter, you've saved somebody's aunt, you've saved somebody's cousin, you've saved somebody's sister. That is, you are preventing that hole in the family that develops because of the death of that individual. This is tissue plasminogen activator. This is my favorite drug. This is an enzyme that digests blood clots. And so why would you do that? Well, the most common type of heart attack is a myocardial infarction. You have a blood clot in the coronary arteries, in the arteries that are supplying blood to the heart, and the heart continues to pump. And if the blood supply is cut off, the heart tissue downstream of that clot begins to die. It would be bad to lose pieces of your heart. So an EMT will inject this. It goes through the bloodstream, goes right to the blood clot, digests the blood clot and restores blood flow and prevents that damage. It's not really very different than putting in Drano and then digesting that clot of hair that is preventing your sink from draining, and then it just goes. Likewise, the most common type of stroke is a blood clot in the arteries that are supplying blood to the brain. And again, all that brain tissue downstream of that begins to die. Now, if that part of the brain is devoted to memory, you lose those memories. If that part of the brain is devoted to motor function, you lose the control of that part of your body. But if the EMT gets there and can inject within 3 hours and can inject TPA, again, it goes to the blood clot and then digests the blood clot, restoring blood flow, and you don't have to lose that function. So is that worth $22,000 a gram? Absolutely. By the way, I worked on TPA with Genentech, and one time I was having dinner with a friend of mine who had worked on TPA, and we were talking about TPA back in the day, and several people in the tables around me at the restaurant overheard TPA, and they said, I don't want to intrude, but they went to my friend and shook his hand, and they said, I had a heart attack and TPA saved my life. So just overhearing it, they couldn't help but come to the table. And that happened. Now, biotechnology isn't only science. We often emphasize the science because the science is so interesting, but it's also engineering, building the equipment, building the machines, and controlling those machines with automation so that the cells will grow in a controlled environment. And of course, medicine, how do the drugs work? Very, very important is business. And business, if you have a biotech company that has great science, but you can't make any money, then this happened locally to two businesses that I just loved. They had great science, but their product wasn't approved before they ran out of money. They had to close the doors. Everyone else had to go get a different job. And that science did not make it to market. So the business side is important. And again, government is important because especially the FDA is going to have to approve your drug in order for a patient to receive that drug. And you're going to have to manufacture it under the very strict scrutiny of the Food and Drug Administration. So all of these are equally important. Often you have people emphasize the science just because it's so interesting, but all of these are equally important. And I'll talk about that. So,
hey, Jim,
yeah, go ahead.
We have a quick question that popped up into the chat. It reads, as a person in the biotechnology field, what are your insights regarding personalized medicine? What would you say its pros and cons in creating pharmaceuticals?
I'll tell you the pros. The pros are you are going to now have medicine that's more effective. So personalized medicine, sometimes it's called precision medicine, is a term that is emerging where you are going to have your genome sequenced and on a stick, and then you're going to hand that to the physician, and the physician says, oh, you have this gene and not that gene, and you have this gene and not that gene. And so what that means is this drug won't work on you, this drug won't work on you. And so we're not even going to try it. We're not going to waste our time. But this drug should work on you. And so we're going to match this drug with you. And so that is medicine that's personalized to you. It can save a ton of money from not wasting your time and wasting that. Another part of precision medicine, though, costs a lot of money. If there's a field called cell therapy, it's basically a cure for cancer. What you do with that field is a patient is a month away from dying. They've been treated with chemotherapy, and their tumor evolved their way around that chemotherapy and came roaring back. And now they have tumors everywhere, and they're going to die within the month. And what you can do is remove their immune cells, remove the type of white blood cells called T cells, and then take them to a company like Juno in Seattle, or like Kite in El Segundo in Southern California. And what that company does is genetically modify them to display a protein on their surface specific for that cancer. And then they grow them up, grow them up, grow them up, grow them up. That is, they expand. So you have a lot of cells, freeze them down, mail them back to the physician. The physician puts them in the body, and those cells go around and kill all the tumor cells, tumor-free in a month. Yes, good. It is called immunotherapy, exactly. And it's specific, and it works like a charm. What's the catch of that precision medicine? The cost. $500,000 a treatment. $500,000 a treatment. So if we do that for all cancer patients, how are you going to pay for it? And that cost has to come down. And so you're exactly right. This is emerging. It's actually here. So Alice says her father went through immunotherapy. Well, that's just fantastic. Alice, if you don't mind me asking, he had a type of leukemia? Melanoma, yep, okay. Okay, well, good. So, excellent. So I'm glad there was a treatment for him. He's cancer-free, yay! And that is why we are in this field. That is why we do this, just for that, yes. So how can we make it more cost efficient? What we have to do is get you into the field and have you be good at it. So we have to improve the process. Okay, so right near San Bruno, right down the hill, the city of South San Francisco. So good, I'll come back to questions in a minute. So the industry started with Genentech in 1976, right near you. That was the start of it, the first biotech company, and created a revolution in biology research and in pharmaceutical manufacturing. And it could only happen in the Bay Area. The science was invented in the Bay Area. At Stanford University, Stanley Cohen discovered or was working with these small circular pieces of DNA called a plasmid that bacteria had. And in South San Francisco, sorry, in the UC San Francisco, Herb Boyer was working on restriction endonucleases, enzymes that cut DNA specifically. And they had lunch one time in Honolulu at a conference, and they said, you know what, if you take my enzymes and cut your plasmid and then take DNA, we could insert the DNA and make a recombinant plasmid, and then we could have as many copies of that piece of DNA as we wanted. So that was the idea, and it came out in the Bay Area. And here's a diagram of it. You cut the plasmid and then insert human DNA for the first time in a bacterial cell, and then seal it with the enzyme ligase, transform a bacterial cell with it, and then now that bacterial cell is making human DNA. If you've genetically engineered this correctly and you have sequences that are recognized by the transcription and translation machinery of the bacterial cell, they will transcribe and translate. They'll transcribe the gene and translate the messenger RNA. And again, for the first time in the history of the planet, a bacterial cell can make a human protein. You put in human sequence, and you then get a human protein. And you can make as much as you want. The first application of this was for the protein insulin. Genentech did that. They didn't have the manufacturing capability, and so they sold that genetically engineered cell to Eli Lilly in Indianapolis, and Eli Lilly made human insulin that way, and it's been made that way ever since. Before this, what Eli Lilly did is they went to slaughterhouses, collected pig pancreases, and isolated pig insulin. It worked okay. It had 50 out of 51 amino acids right, but it wasn't human, and they were running short of it because the incidence of diabetes was going up. And now they have an unlimited supply, and it is flat out human insulin. Good. And here is Genentech, Boyer and Swanson. Now, here is a statue that's on the Genentech campus, and it commemorates a meeting over beer between Swanson and Boyer. So Bob Swanson was a 28-year-old recent graduate of MIT's business school, and he started calling up scientists. Do you think your technology is ready for commercialization? Do you think that we could make a pharmaceutical company that used genetically engineered cells rather than mixing chemicals together in a vat? And all the scientists that he called up were saying, I'm an academic, I don't really know anything about business. And Herb Boyer was the first one that said, yeah, I'll meet with you 10 minutes over a beer in downtown San Francisco. And Herb Boyer was so intrigued that at the 10 minutes stretched out into 3 hours. And at the end of that meeting over beer, they were writing on the back of the envelope, genetic engineering technology, Genentech. And then Herb Boyer borrowed $1,700 from his brother-in-law to hire a lawyer to draw up articles of incorporation, that is to launch the company. And then they needed money. And they rented a place in South San Francisco. And so if you go to South San Francisco now, they rightfully brag that they are the birthplace of biotechnology. Again, let me stress this. This is a multi-trillion-dollar business that's all over the world, and it started a few miles from where you live. Think of that. Think of where you live. You live where this all started. And anyway, we'll come back to the money side. Here is Genentech Vacaville. This is across the street from my facility. This is a huge manufacturing center, the largest of its type in the world. Again, it mainly makes antibodies for immunotherapy. And this one building makes more money per year than Disneyland and Disney World combined. It makes 3 times the money that the NFL makes every year. It makes more money than the entire dairy industry in the state of California. That's how valuable these drugs are. A few years ago, California lost the entire crab industry because there was a toxic phytoplankton and the crabs were poisonous. That's a $50 million per year industry. $50 million, that's one tank. That's the value of one tank. That's how much, that's how valuable these drugs are. And again, they're even more valuable because they're treating diseases for which there are no treatments. And before we go on, what about cancer vaccines? Those are coming. I don't really know much more about that. How can we make immunotherapy more cost efficient? People are working on that. And there's a company that I'll point out in the South San Francisco Bay in Fremont called Allergene, Allogene, and take a look at them. Can this technology be applied to other areas of biology besides the medical field? Exactly. So environmental sciences, it can, but take a look at making new food. Again, making milk without cows, which is a company called Perfect Day Foods in Berkeley. It's an up and coming, making a sweetener without sugar cane or without sugar beets, making meat in a laboratory, again, without animals, using stem cells as a starting material, and making ties out of silk that was produced by a genetically engineered bacteria that had the genes for spider silk put in them, and making spider silk making spider silk in a bacterium and then weaving it into a tie. Artificial bacon is interesting to me. They make that out of fungus. And there is an artificial leather being made out of genetically engineered fungi. And so, yes, the sky's the limit. What a lot of people are working on is genetically engineering organisms in order to make molecules, small molecules, the molecules that are useful in plastic, using a renewable source rather than petrochemicals, rather than going to the refinery and grabbing these chemicals out of crude oil. You feed the genetically engineered cell sugar and it makes these chemicals instead. And making fuels using especially genetically engineered algae, which take carbon dioxide out of the atmosphere, use sun energy, and then make that into fuel. And then that reduces the production of greenhouse gases. And so we will be much, much more environmentally friendly the more that we use biotech to make products rather than fossil fuels. And Nick recommends that you hike through the campus and see the statue. It's by Building 22, by the where they do research. And let me go back to it. There is a ritual that here's the statue, and if you want your experiments to work, rather than throwing coins into a fountain, you put your coins into Herb Boyer's beer mug. So that is a bit of a superstition there. Again, you are in the center of it all. And so here's the way that this typically goes. So you make up media that is cell food, and it has to be sterilely filtered. And you crack open a vial of the frozen cells that have been genetically engineered to produce the product, and then you dilute them into some media, some cell food, and they divide. When they've divided to the right concentration, then you move them into a bigger tank called a bioreactor, dilute this, and again, they'll be diluted first, but they'll divide. When they're close to the maximum, you move them into a bigger tank, dilute them again, that is, add fresh media, they divide, and then you transfer them into a bigger bioreactor, divide, and when they reach their maximum, now you induce them, you trick them to make the protein that's coded for by the gene that you genetically engineered them to have. And then they make that protein for you, and then you put them through a centrifuge to separate the cells from the media. You break open the cells, and then the protein plus all the other cellular components are there. Now you have to isolate your protein of interest away from the cellular components, put it through a few filters, put it through chromatography. If it's an antibody, protein A does a 90% purification right off the bat. All the contaminants go through, and your protein of interest sticks under that particular salt concentration. And then you change the salt concentration or change the pH, and your protein is released. You collect it and inactivate any viruses that may be in there, filter it, put it through several more purification steps, that is chromatography steps, filter it, and then dilute it, surround it with the solution that is going to end up in the final formulation, in the final vial, and then filter. It has to be sterile. Sterilely squirt it into the medicine vials, sterilely add the caps, add the closures, label, package, and send to the physicians. This is sometimes called vial to vial or dock to dock. You have a loading dock where you get raw materials, and the loading dock where you send the finished product. In immunotherapy, it's called needle to needle because the needle comes out of the patient's arm, and the needle puts your immunotherapy product back into the patient via a needle. So why use cells rather than chemicals? Here's aspirin. Again, you mix together chemicals, then they interact in a chemical reaction. It's 21 molecules. An antibody is 25,000 molecules. And the slide I took from Genentech, they compare the complexity of aspirin to an antibody to have the difference in complexity from a bicycle to the 747. That is, it's that much more complex. So it's hard to do this chemically. Although, take a look at Sutro Pharmaceuticals in South San Francisco near you. They have a cell-free process, and so it is possible, and you'll see that. Again, mainly what's being made now is proteins. And you hear a lot about DNA, DNA. I've genetically engineered DNA. I'm putting the DNA in the cell. The DNA is the blueprint. It's the information. But DNA is the flash. Protein is the cache. And that is what you sell typically is protein. And proteins are the tools of the cell. They're the workhorse. If you look at each other, what you see are proteins. And proteins can make up enzymes. Proteins are responsible for locomotion. That is, your muscles can move because of proteins, flagella wave because of proteins. Most of the dry weight in your body are proteins. They're structures. The ligaments that hold your bones together are protein. The tendons that hold muscle to the bone are protein. The scaffolding that your bone, the calcium phosphate of your bone is laid around is protein. And so that makes up more of the structures. Transport, that is the proteins that are transporting materials specifically into your cell and regulate what goes into your cells and what goes out of your cells. Those are protein. Signaling, half of your hormones are protein, and your cells signal to one another using protein. And growth hormone is a protein. Then immune response, the molecules of antibody that circulate in the plasma, the fluid portion of your blood, and bind to and lead to the destruction of foreign objects. Those are protein. So any one of these functions can be substituted for by a protein that's made by a genetically engineered cell. And by the way, remember that proteins form a three-dimensional structure, and the three-dimensional structure is responsible for the function of that protein. And that's the reason why protein products are always injected. They're always parenteral. They are never a protein pill. That if you took a protein pill, the minute that it hit the acid of your stomach, that high acid condition would unfold the protein and make it worthless. Therefore, it's not worth $1 million a gram. You just took the most expensive dietary supplement that you ever had. Good. And just to give you an idea, you might have 100 trillion cells in a bioreactor tank, And that's several order of magnitude greater than the 100 billion stars that are in the Milky Way galaxy. And so in science, you learn scientific notation because the numbers are really, really, really big, or the numbers are really, really, really small. And so you'll be working in picograms, and you'll be working in 10 to the 12th. So the ranges. Here is a picture of Genentech Vacaville, just to give you an idea of the amount of engineering, of the amount of plumbing that it takes to run this. This is a bioreactor, and this is the size of their bioreactors. Their bioreactors are 3 stories tall. The volume in them is, if you can picture this, about the same as the volume in the tanker truck that brings gasoline from the refinery to your gas station. If you think about that volume, these are really, really big. And again, you fill them with mammalian cells in the case of Genentech Vacaville, and they produce antibodies that you then will purify. Here are smaller bioreactors. This is a transfer panel. This is what you look like when you work in this environment. You're gowned up and have a hairnet. The gowning is not to protect you from the product. It's to protect the product from you. Everyone, no matter how clean you are, gives off particles of hair, particles of dried skin. The dried skin may have bacteria on it because you are covered in bacteria. As a matter of fact, all of you, if I were to dissolve you, I would see your outline in bacteria. That's a good thing, not a bad thing. But in this case, we have to protect the product from you. I often think of people walking by that if you could see the particles, it would be like the character Pigpen in the old Charlie Brown cartoon strip and the Charlie Brown animations, where you're leaving this trail of dust behind you, and then you gown up. And this is what a chromatography column looks like at the scale. This may be filled with $1 million of chromatography resin, and here is all of the control to the skid. These are tanks that you use to make buffers, and this is the final automated fill machine where this squirts the finished product into sterile vials in order to make the product. So as this is discussed, how do you ensure the credibility of biotech products? And that is done by the FDA, by the Food and Drug Administration. This field is heavily regulated. It's as heavily regulated as the repair of aircraft at the airport, which is regulated by the FAA. And your college, Skyline College, had a program years ago after 9/11 to train people who were aircraft mechanics to go into biotech, and they had a lot of really transferable skills. It was extraordinarily successful. You got national awards and national recognition for this because the regulation is strict. And so let me ask you, let me just ask you, if you go to CVS Pharmacy and you go to the shelf and you take a bottle of aspirin, so here's a bottle of aspirin, and what's your confidence that this is aspirin? How confident are you that it's really aspirin in here? So what do you think? Here, I'm going to take a baby aspirin right now. Take one every day. Okay. Orange. Orange flavor. You're not confident? I'll take another one. I'm pretty confident. Aren't you? I'm 100% confident. This is aspirin. And it says 50 milligrams per dose. I just took a pill. How confident am I that that's 50%? Sorry, that's 50 milligrams. I'm really confident. Why? Why? Because we know the Food and Drug Administration is regulating it, and we know that they are really, really, really strict. So Good, because of FDA approval. And really, it's the FDA that gains, or that is responsible really for the credibility of pharmaceuticals, the credibility of biotech. You're not going to get anything past them. They are ultra strict. Now, let me ask you, I'm going to go and get a herbal extract from the vitamin store. What's my confidence level there? Terrible. Why? Yeah, so 10% maybe, I'll say 66%, because when a study was done that took all the herbal extracts on the shelf and did DNA sequencing of them, 1 out of 3 had no trace of the plant that was on the label. 1 out of 3. And so it's 66%. It is not a pharmaceutical, but it may have pharmaceutical properties. It is a drug, and the Congress specifically removed FDA regulation of dietary supplements from, they took that power away from the FDA. And so I recommend go to YouTube and in YouTube look at the John Oliver, and he's a comedian, but he does sort of exposés, and Dr. Oz. And he takes Dr. Oz to task for all of the promotion of dietary supplements, which is complete nonsense. And again, dietary supplements, they are flat out potentially dangerous because of the FDA. Good. So current and future of biotechnology. So we've been talking about the importance of biotech to therapies and to making drugs. And this is extraordinarily important. Again, often these proteins that are made will address a medical condition for which there's no treatment. Again, not for which there's no cure, for which there's no treatment. And there are many, many parents that have a son or daughter with a medical condition, and they're just, okay, hurry up, biotech, hurry up. I need this to treat my son or daughter. But as we talked about before, it isn't only medicines that, and again, there's a lot of activity locally if you're into this. So what they're calling clean meats, because lab grown meats or biotech meats, they're afraid that an opposition is going to arise to call them Franken meats or something. But lab grown meats, and again, it's really environmentally destructive to have cattle everywhere. And so there's a lot of cool things, making fish patties using fish stem cells. There, you just have to get the cost below where meat is. You've probably had Impossible Burger, again, a Bay Area company. Impossible Burger, you can get an Impossible Burger Whopper at Burger King. I like them. They're good. I like them as well as I like hamburgers. And what they do there is they have a type of hemoglobin from plants that is red, and it makes it look like it bleeds. That is, it makes it look, makes a plant-based burger look more like real hamburger. But there are others. Memphis Meats has a outpost in Sacramento, and there are many people working on this. Stem cell therapy. Remember, woohoo! Prop 14 just passed. The state of California just passed an initiative in November to put $5.5 billion into stem cell research, and half of you are going to be treated with stem cells in your lifetime. There's a really, really good program for stem cells at City College of San Francisco, which is on the BART station, not all that far from you. Gene therapy, again, making up for damaged or missing genes in children that inherited a genetic disorder. What you do there is you genetically engineer a virus. You take out the guts, you take out the viral nucleic acid, and you put in the missing gene, and then the virus serves as a delivery system into the appropriate cells, delivering that missing information and compensating and preventing usually the steady degeneration of that patient. Personalized medicine, we talked about, again, tailoring a treatment with genetic knowledge to an individual. Now, what this requires is the Affordable Care Act. It requires a prohibition against discrimination based on a pre-existing condition. Remember, you can save a lot of money in medicine, save a lot, if you can do a diagnostic test before that says this is going to work, this treatment will work, this treatment won't work. You save the money of trying something that isn't going to work. But that is all predicated on someone subjecting themselves to that diagnostic procedure. They have to be protected, because if you find something and they're going to be discriminated against based on what you find, based on their genetics, no one's going to subject themselves to that diagnostic procedure. So that's important. A forensic investigation, you know about this, that many people have been freed from jail. Last I checked, it was around 200 people were freed from jail based on looking at DNA. They were convicted under false evidence, or under really what usually happens here is everyone wants that dramatic place in the courtroom where you were present there the night of the murder. Yes, I was. And did you see the person? Yes. And is the person in this room? He's right there. May the record reflect that the witness identified the defendant. It turns out that eyewitness is the worst piece of evidence that you have. It's usually dark. Somebody is shocked and they turn and they see something, and then they'll piece it together. The trial occurs years after. It's terrible evidence. It's what the jury wants to see. A lot of people are convicted on it, but it's the forensic evidence that is much more reliable. New pharmaceuticals, again, take a look at the diseases, and there's a lot of work, especially with our friends at BioMarin across the bridge from you in Novato. They're treating what are called orphan diseases, these diseases that are relatively rare, and that there aren't that many people who have them, but now we're treating those patients. And it's an interesting thing here, the way that this goes, that because there are so few patients, you have to charge a lot of money. Well, you charge a lot of money, and it sounds like, wow, you charged $500,000 for that treatment. But consider the cost of not treating that person. They're going to slowly get worse and worse. They're going to lose the ability to walk, and now they're in a wheelchair, lose the ability to stay in the wheelchair. Oh, now they need intensive nursing care. They're in and out of the hospital. Oh, now they'll need 24/7. Oh, now you move them into hospice, and ultimately they die, but they die chewing through healthcare costs. And there's a lot of talk about the high cost of pharmaceuticals. Yes, that's true. These drugs look really expensive, but very, very often the cost of not treating people is even more expensive. If a really, really expensive pharmaceutical can save a single night in the hospital, it probably paid for itself because hospitalization is so expensive. Again, new foods, and there's some neat things. New nutrition. Remember, the plants evolved, the plants that you eat evolved not to provide you nutrition. They didn't want to provide you nutrition. You're ripping them off. And so they have wrong, they have ratios of amino acids that are good for them, but not necessarily good for you. We can genetically engineer them to be better for us. We can genetically engineer them to contain vitamins that they don't naturally have. So again, the combination of nutrition and pharmaceutical. New materials, so we can build new, stronger materials, make bulletproof vests out of spider silk, so that they're sort of like the the vest that Bilbo Baggins or Frodo Baggins wears, made by elves, that protects you, and they're really lightweight. Again, biofuels, it's crazy, spewing all of this carbon dioxide in the air. We can have the carbon dioxide, we can go carbon neutral. Addressing aging, this is an interesting one. It isn't clear that you have to age. Aging is likely a programmed self-destruction by genes in your body to get you out of the way for the next generation. Synthetic biology, including do-it-yourself, making life out of chemicals, making life from scratch, and doing it in your garage. So if you want to order a kit from the Odin, another Bay Area company, you could genetically engineer frogs with a growth hormone gene and make mega frogs. Making things, living foundries, designer organisms. Can we engineer a Pokemon? But more than that, can we bring extinct organisms back? DNA storage, it turns out DNA is one of the best ways to store information. It's better than electronic, certainly better than books and paper. And so all of the sonnets of Shakespeare have been coded in DNA and stored in a solution. You could do that for the Library of Congress, and people likely will. Brain-machine interfaces, you can send genetically engineered algae to Mars and have it produce an atmosphere for you and terraform it. And anyway, add to this list yourself. You can be part of this movement. Again, right now the emphasis is in pharmaceuticals, but a lot of people are looking at other than pharmaceuticals in order to transfer our lives. This is the century of biotechnology. You are in the center of the entire world in biotechnology. You couldn't have chosen a better time to go into biotechnology. Now, where are you going to go into biotechnology? Well, you have an excellent biotechnology program there at Skyline College, and you can get a certificate and an associate's degree. And then if you would like, you can transfer seamlessly into our baccalaureate degree. Our degree is in biomanufacturing, teaching the skills and knowledge to go in the manufacturing sector of biotech rather than into research, although you can go into research. And what we've recently negotiated is a guaranteed admission into graduate school, so you can get a master's or a PhD in biomanufacturing, beginning to end under $10,000. So you can exit college without debt, and you can exit to get a job with a biotech company at any point. If you get employed by a biotech company, they will pay your additional, they'll reimburse you for any tuition here, and they will pay for your graduate training. Most of our graduates end up getting a master's degree. They said, as long as they're going to pay me, I'll get a master's degree. Many of our graduates transferred to UC Davis or UC Berkeley and had the company paid for their additional schooling and exited college without debt, which is a remarkable thing nowadays. So I'll end there and take questions. What are the problems, challenges has the biotech industry faced when developing personalized medicine, and how did they overcome these issues? Yeah, and I've already outlined the main problem is cost. The main problem is it's easy to do it the old way, where I'm going to grow up one tank and develop a product that I can then give to 50,000 patients and make a profit off of giving it to those 50,000 patients. It's much, much harder if I'm going to make this drug for this individual. And really, the main thing is cost. And how do you overcome it? You just get better and better and better at doing that. As someone interested in to be a veterinarian is a good route to be a biotech major. Yes, it is. So you're probably going to go either biology or biotech. You're going to add zoology courses. My strong recommendation for anyone who is interested in going into veterinary school or into a professional school, into medical school, into pharmacy school is a volunteer. So if you want to be a veterinarian, volunteer at a veterinarian's office. Make sure that you like it. You like the real day-to-day operation of that field before you commit to 4 years. There's nothing more tragic, and this happened to some of our students that, oh, I went to medical school, but in the end, I really don't like being a doctor. I don't like being a physician, but I have to because I'm $200,000 in debt. So make sure that you like it. Do you think CRISPR-Cas9 technology will be the future of biotech, reaching every aspect of medicine, treatment, and pharmaceuticals? Yes, that is going to be hugely important. And there are other gene editing technologies, not just CRISPR-Cas9, and but it is going to be huge, and you're already seeing it. Take a look first, though. That's going to be used to genetically manipulate crops before it really has a practical application in humans, but certainly it is coming. That company that I talked about, Allogene, uses gene editing technology. It uses zinc finger nucleases rather than CRISPR. Not necessarily, CRISPR is probably better, but that's the technology that they have the patent for. And what they do is they go into a immune cell and they remove the genes that code for the cell surface proteins that would make the body react to it, that make a patient's body react to it. And they also remove the genes that would make that cell react to the body. What advice would you give to future biotech students or current biotech students to further their education in biotechnology? So I would consider finishing your biotech program and maybe get a job and try it, and make some money and see if you like it. We're going to have a class in the summer, a 1-week class that I'll invite you to attend. And by the end of the week, we'll have you gown up, we'll have you grow cells, we'll have you break the cells open, we'll have you isolate the protein, and you'll go home with protein in a vial. And by the end of that, you should be able to know whether or not you like the field. Can I comment on the Solano cell and gene therapy certification in terms of the prospect, or the student needs to go for the bachelor's MS degree? No, you will be able to work as a technician in cell and gene therapy with a certificate. And we have a grant where we are interviewing members of industry all around the country. We were in San Diego last week, we're in Seattle this week, we're in San Francisco Bay the following week, and we're in Philadelphia the following week, and asking the companies what should students know in order to go into cell and gene therapy. I have to tell you, the way I really where gene therapy and cell therapy caught my attention is we had some of our graduates at Genentech across the street from us, and they were lured away from Genentech by Juno in Seattle, who told them, if you move to Seattle, we'll give you a signing bonus. We'll rent you a car for 3 months. We will rent an apartment for you for 3 months until you can find your own. If you want to buy a house, we have our own real estate agent, and they won't charge you commission. And anyway, I thought, whoa, okay, you got my attention. So this is an emerging field, cell and gene therapy. There are 185 gene therapy companies in the Bay Area. Again, you're in the center of it. Almost all of them are in South San Francisco. Again, if you go down Highway 101, go down Interstate 101, and you go through the city of South San Francisco, you'll turn and see South San Francisco, the industrial city on San Bruno Mountain. But then when you turn back, don't do this if you're driving. When you turn back, there are crane after crane after crane after crane after crane building new buildings. All of those buildings are biotech, all of them, every single one of them. Recently, in the last few years, the builders built 1 million square feet of laboratory space in that corridor. All of it is filled. They're going to build 1 million more. All of that's going to be filled. There's a huge cluster in Mission Bay near where the new Golden State Warriors Stadium is, right there. Again, every time I go down there, there are crane after crane after crane, all biotech, all biotech. It's all biotech. You're in the center of the world for it. So again, if and that what I didn't mention is the biotech companies often allow you to buy their stock, and you buy their stock at a discount of 15%. Now, I just checked it today. My savings account is making 0.1%. So 15%, if the stock doesn't go up, you've made 15% off of your money. This is the way toward wealth, and you can jump in really right away with your Skyline biotech training, and then again, usually the way this goes, you're hired by a temp agency as a probational worker. It'll take you 6 months to a year to be hired by the company itself, and then but once you're hired by the company, they'll pay for your additional schooling. Let's see. You said biotech is the way to go for anyone. As someone whose major is in biology and who isn't that math, science savvy or smart, but is interested in medicine, what is your way to go in your opinion? There's a spot for you. There is a spot for you. I guarantee there's a spot for you. A lot of people get interested in the regulations, and so I'm not very sciencey. A lot of people at Genentech, they have a bachelor's degree in communication, and they just learn the science. Yeah, you'll be fine. It sounds more sciencey than it is. It does. It really does. There's a spot for you. Are there short training programs, less than a year, which is for biotechnicians? Yes, as a matter of fact, this summer, we have a program where we took our entire year and compressed it into a 8-week boot camp. And so you can get our certificate in 8 weeks. It's pretty intense. It's 8 to 5, Monday through Friday. And so when I teach them that, I have to go home and take a nap. It's pretty intense, but there is a way to do it. Do some companies give internships in the field of biotech? Yes, there are some internships. And I'll share with you, though, I don't have my students get internships myself. Nick, you want to talk more about this? I usually emphasize the students, get a job, get paid, rather than going to internship. Nick, can you help me with this?
Yeah, I mean, kind of same thing with us. There's enough jobs out there. You can apply for the jobs. There are some internships, and we do have a department that will help students kind of look for the internships that they can get. Again, all these internships are very competitive around the area. So Genentech has internships where they get people from all over the world that come in and do their internships. And we'll get a few of our students to go in there, but again, you're competing with other people. But I think what Jim says is, you should really try and take the classes and apply for the job.
And that's where so we we have a lot of graduates that again moved up. Now they make a lot more money than I do, and I went to college for 12 years. So anyway, right. Any other questions? I've gone over a little
Jim,
bit.
can I put a plug in? So Skyline College does have a program. We have a 1-year and a 2-year certificate program, and we do have programs that will help people get certificates. And so if you are in a nursing program and you didn't get into nursing this year, come in, take the biotech program, because you'll keep up your skills. We do look for kind of internships for people. And then, we get a lot of people in biotech that want to be nurses, and they realize that they don't really want to be nurses. They don't like sick people, but they want to have the skills to make medicine.
Body fluids.
And the patients are okay, but I don't necessarily want to deal with their families and stuff. That's another big one too.
And if you think about it, we have the same. We have a lot of our biotech students that had an aspiration for nursing, mainly because they didn't know what biotech is. But think about nursing. You're going to take the prerequisites for 2 years, usually, micro, chemistry, anatomy, physiology. Okay, so now 2 years, now I'm going to apply. Well, I didn't get in this year, I'm going to apply again next year. Oh, I didn't get in, I'm going to apply again next year. Now I have a Okay, now I have 2 years in nursing school. Well, gosh, that's 6 years, right? In biotech, you can take 1 year, get in the job, and make about as much as you're going to make as a starting nurse on the other end, and then move up from there. And so, really, in terms of time, you're saving at least 3 years, maybe 5 years.
But so Jim, so I mean, one thing, Brittany, that you have is, so Skyline has a 1-year certificate program. And like we said, we encourage people to go out and start applying for jobs. So you have that 1 year of training and you start entry-level position, and then you can take your second year. The great thing about California community colleges is that Jim has a program where they have a bachelor's program. So Jim, how much is it per unit? Are you guys charging?
It's 130 per unit. It's not, of course, it's state mandated. We didn't, but rather than the $46 per unit. And again, if you're on a Board of Governors fee waiver, you can have that 46 waived, but not the extra 84.
But about you, I think you've done the calculations. How much would it cost you to get your bachelor's to go through?
Yes. So if you had to pay the whole thing, the second 2 years is about $5,000.
Yeah, for a bachelor's.
Yep.
So rather than $5,000 for a semester, like another campus, you're getting your whole bachelor's.
Right.
So.
All right. So on that note, I just want to be mindful of everyone's time. We went a little bit over, but didn't want to intrude or interrupt on the great question and answers. I appreciate all of you for still sticking it out on the call. For those of you that are on here, I want to especially thank Jim for spending this last hour and 15, 20 minutes or so now presenting some of the great opportunities within the biotech field. Really wanted to thank you. I'm just going to go ahead and end the recording at this time as well. Science in Action is offered every Tuesday, 4:30 to 5:30 right here on the Zoom call. If you are watching this on YouTube, we try to upload every week with the most recent Science in Action presentation. Jim, thank you again for your time this afternoon/evening with us.
Thanks so much. And it's my pleasure. And thank you for inviting me. And Nick knows my email, and I'll send you these slides and my emails on the front of it. So okay. If anyone has additional questions to follow up.
Yeah, and if you have the summer boot up camp, if you guys are going to be doing this in person this summer, if you want to send me that email, I'll distribute it to people and stuff as well.
Thanks, Nick.